Okay, so we are still back on this stem and leaf plot. We're given a stem and leaf plot, and these are the Falcons football game for the season. Falcons football game for the season. And we are not told to put it in a frequency table, but we want to put it in a frequency table. So frequency table of that. It is not a grouped frequency table. It's not a group frequency table. So there are stem five, there are six. Six of them is in the 50s, six of them in the 70s, five of them in the 80s and the 70s, and three in the 80s. So if I'm told to find relative frequency, what is the probability that they scored in the 50s? 6 out of 20. There are 20 gains. We're talking about relative frequency again. Just know that relative frequency is the same as probability. Okay, well, what is the probability that they scored in their 60s? 6 out of 20. What is the probability that they scored in their 70s? 5 out of 20. What is the probability that they scores in their 80s, or maybe greater than 80 or more? 3 out of 20. And the question here is, what is the probability that the Falcons will score more than 80 points in their next game? So if it is more than, then it's only 1 out of 20, because the question says more than. So we have to be very careful. The question says more than. The question says more than, that's only one more than. Say there are 2 80s here. So more than 80 will be 1 out of 20. And 1 out of 20 is the sentence as 5%. So 1 out of 20 multiplied, if I'm told to read my answer in percent, so nearest tenth or percent, leave my answer. So I multiply that by 100 over 1, and so I have 5. So the Falcons scored 5% because there's only one score that is greater than 80. That's only one score that is greater than 80. I hope you understand the question. Use the plots to predict the probability that the Falcons will score more than 80 points in the next game. More than 80 is no more than 80. So there are 2 80s here, 80 here, 80 here. So that's only one number more than 80. One number more than 80. So that is the place where Falcons scored. And what if you are told to find the mean for the whole season, the median? What about it? What if you're told to find the standard deviation? You might be told to do that. So in other words, you should be able to read the frequency distribution. You should be able to read the frequency distribution. So you go back and so I'm going to go ahead and pull my calculator and put all these numbers in my calculator. All right, so is my calculator not opening? Calculator refused to open. Okay. There are you here, so okay. You to wow, finally you opened. All right, my calculator is open now. So I'm told to, the question is, if you are told to find the mean, median, and mode, find the variance and standard deviation, and when you are given the data in stem and leaf, you should be able to read. The first one is 52, and the largest number is 81. You could be told to find the range. The range is 81 minus 52. You could be told to find the 5-number summary. You could be told to find the quartiles. So let's find all of them already. So the first thing is you should be able to read the stem and leaf plots. So the first number is 52. So be careful. We are going to be typing the number in. So the first number is 52. I can just put it in my first number is 52. Enter. And I'm putting the L1. Second number is 55. The third number is 57. Another 57. Another 50. I have 59. And another 59. So these are the numbers under 5. Then what are the numbers under 6? 62. So 62. The next one is 63. The next one is 65. The next one is 68. So you should actually be able to read a stem and leaf plot and find the actual data, the original data. 69 and 69 again. And the next one is 71, 71. The next one is 72. The next one is 75. The next one is 75. And the next one is 78. All right, so the next number is 80. The next number is 80. And the next number is 81. There should be 20 of them. So there should be 20 of them, and I have 20 of them. The next thing is to eyeball the data I put in. Do I have all the 2-digit data? Because you can make a mistake. If you make a mistake, you should be able to correct yourself early. So I have data ranging from 52 to 81. So the next thing I want to do, this is already arranged in ascending order. I could be told to find the 5-number summary, the mean, the median. I could be told to find the, this is a sample. So I'll be told to find the sample standard deviation. So let's do that. Go to start, arrow to calc, find one variable start. So when I find the one variable start of the data in L1, this data is not a group data. So I'm going to calculate. So the mean score for this is 67.35. So the mean score is 67.35. If I'm told to find the standard deviation, this is a sample standard deviation. So the sample standard deviation is 9.098 to 3 decimal places. 9.098 to 3 decimal places. And if I'm told to find the range, it is already 81 minus 52. If I'm told to find the 5-number summary, if I can do one variable start, I can find the 5-number summary. So these are the 5-number summary. The third quartile is 75. 75 is greater than the rest of the scores. The median is 68.5. And I can be asked if the data is skewed right or skewed left. Remember, if a data is skewed right, the mean is greater than the median. But this data looks like it's skewed left. So let's see what the mean is again. Let's see what the mean is. The mean is 67, but the median is 68.7. So this data is skewed left because the median is greater than the median. This data is skewed left. The first quartile is 59. Therefore, if I'm told to find the interquartile range is 75 minus 59. The interquartile range is 75 minus 59. So I can quickly take a picture of that and find all the missing numbers. Okay. So now I want to, I can list the 5-number summary, or I can actually use my calculator and draw a box plot. So let's draw a box plot. Box plot is also the graph of a quantitative variable. So second start plot, I select plot 1. My plots are turned off. I will turn it on, arrow down, and then I selected box plots. My data is in L1, so this is good. This is not a group data, so I am going to just do zoom 9. So zoom 9, and when I want to do zoom 9, I'll see this argument. I'll second quit, then I'll zoom 9 again, zoom 9. Okay, then I'll push trace. The median, as we already know, is 68.5. The median is greater than the mean. You can already see that this data is longer on the left-hand side. Therefore, this data is skewed left. The left whisker is longer than the right one. So this data is skewed left. If I want to find the first quartile from my box plot, this is the first quartile. And the first quartile is 59. The minimum number I already know is 52. I can also arrow to the right and I find the third quartile, which is 75. We already saw that. And the maximum number we already know is 81. So I can be told to find the 5-number summary, the interquartile range. So the interquartile range will be Q3, which is 75 minus Q1. So the interquartile range is 75 minus 59. All right, so you subtract the 75 minus 59 is the interquartile range. So we kind of talked about what we expanded what we talked about the other day. You could be given a stem and leaf plot, and you are told to read the plot, organize the plot, read it, find the original data, find the range, and you can be told to use that data to find the relative frequency. You can use it to find the cumulative relative frequency. You can, of course, you already know that relative frequency is the same as probability. Also, you can be given a stem and leaf plot and you're told to find the 5-number summary, like we just did. You could be told to draw a box plot, find the interquartile range, find the mean, median, and mode, or say whether the data is skewed left or skewed right. We already know that this data is skewed right because the mean, this data is skewed left. The data is skewed left. Why? Because the mean is less than the median. So the data we are talking about is skewed left. When the data is skewed left, it's negatively skewed. The mean is less than the median. The median is Q2. And the median was 68.5. And the mean was 67. You look at my screenshot. All right, so the mean is 67 point something. So this data is skewed left. Data is skewed left because the quartile, second quartile is greater than the mean. We already found that the probability that the Falcons will score more than 80 is 1 out of 20. Because what happened here? That's only one score. Only one score is greater than 80. So the probability that the Falcons will score more than 80 games is only 1 out of 20. That's only one score that is greater than. That's probability. You could be told to leave your answer in percent, like here. So multiply 1 out of 20 by 100, and your answer is 5%. So that probability is 5%. Your answer in probability or relative frequency can be in percent, decimal, or fraction. Your answer can be in percent, decimal, or fraction. All right.